Hello, welcome to section 1.2. So this is really a lot of basic information, some of the vocabulary that we're going to be using in this section, or at least kind of the building blocks of the whole chapter. So I know that these are kind of small, they will be posted as well, but here is me in case you would like to hear an explanation. So basically some of the vocabulary that we're going to be using in this chapter is the idea of a point. It's pretty much just a dot. It indicates just one specific point in space somewhere, no size, no dimension, and it's named with a capital letter. A line is a straight path. It has no end in either direction, named with 2 points on the line. Any 2 points are fine. Can be named with a single letter as long as that is not a point on the line. So I could call this line D, but I could not name it line N. And if it doesn't come with a letter already, I really can't just make one up. I should name it by the points then. A plane is just a flat surface. It has no end. It has no thickness. Contains infinitely many lines and points. It's named by a single letter. In this case, I could call this plane R because there's no dot by the R. It's not a point. Or I could name it with any 3 points that are on the plane, as long as those 3 points are not in one line. So X, I, D, whatever, L, I, V. That's how I could name that plane. Collinear points. Again, that prefix co means with, so it's basically points all on the same line. So W, O, T are all collinear. Q is not. Coplanar points. Same idea, but points all on the same plane. So again, X, D, I are all on the same plane. Actually, all of these points would be on the same plane. A segment is just part of a line. It has 2 endpoints. I could name it either way, KM, MK. It's the same segment. It doesn't matter. A ray is also a part of a line, but it has only one endpoint, and then it keeps on going all in the same direction indefinitely. So the order of points does matter because it's kind of indicating the direction of the ray. So for example, I have to name based on the endpoint, which strangely enough is actually the starting point, and then the letter that indicates the direction the ray is going. So this is ray BG, and I'm naming it ray BG, and here's my arrow. Now the thing with the symbol, the arrow is always going to point to the right no matter what. To understand what ray you're talking about, again, it's the order of the letters. The first letter is the endpoint, and the second letter is the direction that the ray is going in. So these are talking about opposite rays. Opposite rays share the same endpoint but go in opposite directions. And here's a little bit where the naming idea comes into play. So opposite rays here on this line would be OF and OV, because both of those are starting at O, or the end point is O, but one ray is going in the direction of F and the other ray is going in the direction of V. But you can see here when I name those rays, no matter what, the symbol was pointing to the right. It's the letters that tell me the direction of the ray, not the direction of the symbol. So some postulates that go along with this that you kind of keep in mind when you're trying to do some work and figure some things out is that through any 2 points, there is exactly one line. If 2 lines intersect, they intersect in exactly 1 point. So for example, if I drew 2 lines here, they're intersecting in exactly that 1 point. If 2 planes intersect, they intersect in exactly 1 line. And probably the best way to understand that is if you're just in your house and you look at a room and you see the wall and the floor. The intersection of the wall and the floor is that whole length where those 2 parts of your house are connected. And then the last postulate here is through any 3 non-collinear points, there is exactly 1 plane. So when it comes to actually figuring all this out and naming them, here's this example here. So here's a line. You can see there are arrows on both sides of the line. I have 3 points on the line and then this lowercase p. So 4 different names for the line. Again, I can name it with any 2 points. So SJ, SA, JA, or I could name it with just this lowercase p. Again, I could have named it line JS, AS, or AJ, all the same line. 3 line segments, those are just pieces of the line. So SJ is one piece of the line, JA is another piece of the line, and SA is another piece of the line. And again, JS would be the exact same segment, AJ would be the same as this, and AS would be the same segment as this. The order of the letters doesn't matter. 4 different rays, I have to pay a little bit more close attention because here the order actually does matter. So if I'm looking at the end point or the starting point, however my mind processes it better, if I'm looking at ray SA, that's telling me it starts here at S and goes in the direction of A. JA starts at J and goes in the direction of A. So different rays because they had different endpoints. AJ starts at A and goes in the direction of J. These are not the same ray because the endpoint and the direction were different. And JS starts at J and goes in the direction of S. So again, if I were naming this, SJ and SA are actually the same ray because both have the same endpoint or starting point and are going in the same direction. Same with AJ and AS. AJ and AS are the same ray because they have the same endpoint and both go in the same direction. 2 opposite rays, I really only have one choice for that set, JA and JS. They both have the same endpoint and are going in 2 different directions. And then 2 points, just any point on the line. So S is a point, A is a point. I could have named J, that's a point also. And then finally, looking at a little bit more complex of a figure, here I have my good old friend, the rectangular prism. So I'm looking here for 4 pairs of line segments that do intersect. So that means that they're just going to touch each other in one point in this figure somewhere. So if I'm looking at GA and AB, here's GA, here's AB, they're intersecting there at point A. EF and FC. So EF is back here, FC is right here, they're intersecting at point F. DE and EG, here and here, they're intersecting in point E. And AD and DE, AD is here, DE is here, so they're intersecting in point D. And even if I couldn't quite tell from this figure, I would actually be able to tell by the names over here because where they are intersecting, it's sharing that letter. So GA and AB are intersecting at A. EF and FC are intersecting at F. DE and EG are intersecting at E. And AD and DE are intersecting at D. 2 pairs of line segments that do not intersect. I'm just looking for something that no matter how far I extended the line, they would still never run into each other. So I have GH and AB. So GH is right here and AB is right here. So again, no matter how far out I extended those pieces, they're parallel, they're never going to run into each other. DE and BH. So DE is here, BH is here. Again, no matter how far I extended those lines, they would never run into each other. 3 different planes. I have plane DEC, DEC, 3 letters. Again, F is on that same plane, so I could have incorporated the letter F into that name. It doesn't matter. The combination of the 3 letters is indicating this plane, which the way I'm looking at it is the bottom of the box. Plane FHB, FHB, same thing. C is also on that plane, so I could have incorporated the letter C in the name. Either way, it's how I'm looking at this is the right side of the box. plane DEH. Okay, well, D is here, E is here, and H is here. So I did this on purpose because this is often something that people miss. And I'm going to look at it two different ways. One is, even though the plane isn't necessarily drawn in, I can still envision that there's a plane going diagonally through the middle of this box. And that is the plane that would have points D, E, and H all on it, the diagonal through the middle. However, I could think back to the postulate that was on the previous couple pages ago and remember that through any three non-collinear points lies one plane. So here are 3 points, not on the same line, so one plane has to go through them. Then 4 non-coplanar points, that's 4 points not on the same plane. Well, being that through any 3 points is a plane, easiest thing to do when you have to identify this is just find a plane, name 3 letters on it, and then pick a 4th letter that's not on that one. So I just happen to choose ADG. So if I look at ADG, I could think about that as the left side of the box. So I just picked H because H is definitely not on the left side of the box. So again, you can't find 4 that all together are on 4 separate planes because of that postulate that says through any 3 non-collinear points has to be a plane. So you just find 3 that are on the same plane and then pick the 4th one that you know is not on that. So that should be enough to get you through the beginning exercises for that chapter. So I will see you again in section 1.3.